In this video, we will take a look at systems of equations involving quadratic equations. So if you remember back in chapter 6, we did systems of equations, what they were linear, so we wanted to find where did the two lines cross, and that point was the solution to our system. So we had three different ways to solve systems. We graphed them, which remember was not very accurate. We did substitution or elimination. And you know that we could, for two lines, we could have one solution, no solutions, or infinitely many solutions. All right, so now we're going to look at systems where one equation is linear, it's a line, and the other equation is quadratic, or it's a degree 2. So there are two ways that we are going to solve these systems. We're going to use substitution, and we're also going to graph them. But before we get into it, I want you to turn the page and take a look at the three different scenarios that we could have. Of course, the quadratic will graph to a parabola. We could have a line. This would be no solutions. Or we could have a parabola where the line just touches in one point. That's called a point of tangency. It's where they touch in one point. That would be one solution. Or the line could cut right through the parabola and we would have two solutions to our system. Okay, so before we do the substitution, which will be the bulk of how we solve these problems, I want to show you again how to graph on your graphing calculator. So you all are heading off to 9th grade in just a few months, and you will probably be required to have a graphing calculator. Most schools that I've taught at use the TI. You might be going to a school that uses, I can't remember the other kind. But anyways, if you went out to get a TI 83 or 84, and I would pay to get the ones that are thin. This one's kind of old. Mr. Avard bought it for me. Thought it was cool. You could get a pink graphing calculator. But anyways, I'm going to walk through graphing this system with you. So what I was going to say is you're going to have one of these eventually. If you want to order one now or go to the store and get one now, it might be a good idea just so you get familiar with how to use these. So remember, right up here is our y equal button. Looks like I've got some equations in there from last time. Y equal, and we can go ahead and put in the very first equation. 3x plus 2 will look like this. We got the 3 down here. Here is your x plus 2. And then let's go down and put in the 3x squared plus 6x plus 2. So in the second y, that's y sub 2, 3x, remember use the caret, squared. Some of these you have to bump over, plus 6x plus 2. Alrighty, and then if you looked through the solutions videos, we kind of talked about this, but our window is going to show us where we want our graph to be. And normally we use a negative 10 to 10 and a scale of 1 for both the x and the y if we're just throwing something out there on the graph. Depending on the context of the problem, you might want to adjust that. So now we graph. And here goes y1, and then there is y2. And you can also zoom. If we zoom in a click, that's exactly what will happen. We can zoom in a little bit and see what's going on a little bit better. And we can see that we are going to get two solutions. Now, what are they? If we wanted to use our graphing calculator to find out what those points are, we could use this calculate right here. So we go second calculate. We want to find the point of intersection. So we go down here, intersect. And then remember how it says first curve, second curve? So I can't really see where it is, but it looks like it's on one, and then it's going to drop to the other second curve. Yes, I'm just pressing the enter button here. When it says guess, you just press enter again, And that's our first point of intersection. X equals 0, y equals 2. Let me go ahead and write that down here. So by graphing, we have the point 0, comma 2. And then let's go over and find this point of intersection. So we go back to second calculate, go down to intersection, and then we're going to scroll over here. Here's a little hint. Never go up and down. When you go up and down, your cursor hops off the graph. We don't want that. We just can only go right and left when we scroll. So we're just getting closer to this point of intersection. I'm on the first curve and the second curve. Do you see how it's on the parabola now? And then when we push the enter button, what your calculator does is called an iteration, where it moves in and it finds this point of intersection, which is -1, comma -1. -1, comma -1. So when you go to 9th grade, if you can graph functions and find their point of intersection, you will be ahead of the curve. Haha, get it? All right. So, lame joke. Sorry about that. So here's what we found graphing. Now we're going to use an algebraic method and solve this system using substitution, and we should get these answers. Okay, 2 ways to do the same kind of problem. Of course, if you're stranded on a desert island, you probably wouldn't be graphing it. Okay, so we have y equals this and y equals that. You know, the substitution property says that if these things are both equal and they're, of course, the same, then these two expressions are equal to each other. So that's basically what we do. And I'm just going to start with my 3x squared on the left. And I'm going to say that's equal to 3x plus 2. They're both equal to y, so therefore they must be equal to each other. All right, let's turn our minds now into solving quadratic mode. And when we solve quadratics, we want all of the terms on the left and set it equal to 0. We always do that when we have x squared terms and x terms. We always have to set it equal to 0. So let's subtract this off, minus 3x, and subtract the 2, minus 3x. And we would have 3x squared plus 3x is equal to 0. All right, at this point in time, I could put this into the quadratic formula, which is nasty, or I could factor it. I have a greatest common factor. It's one of those type of problems. I could factor out a 3x, and then I would have x plus 1, and this is equal to 0. And then now we apply the zero product property. 3x equals 0, or x plus 1 is equal to 0. So when we divide by 3, x is equal to 0. And when we subtract 1, x is equal to -1. All right, we found the two x coordinates, but solving the system, remember, is those points of intersection. Each point has an x and a y coordinate. So what we need to do now is to put this value into this equation or this equation to find our y. It should not matter if it's a point of intersection, the y value will be the same. And 0 is pretty easy to do. If we put the 0 in here, y equals 2. If we put the 0 in here, y equals 2. So we have the point 0, comma 2, which is what we got graphing, right? So here's the solution, the point 0, comma 2. And here, if x equals -1, -3 plus 2 is a -1. Y equals -1. Why am I using this one instead of this? Because this is easier. We should get the same. Let's do it real quick. -1 quantity squared is a +1. 3 times 1 plus 6 times -1. 3 minus 6 is -3 plus 2, -1. That was fast, but... Okay, so 2 ways to solve a system: substitution, which is all algebraic, or graphing, which is something that if you have a graphing calculator, you can try. Of course, you could always graph those by hand, but you don't have to. Okie dokie. So let's go back to this that we talked about. We had three possibilities. We could have no solutions, one solution, or two solution. Remember this? What does this mean algebraically? Well, it has to do with this guy here in the quadratic formula, the b squared minus 4ac. Now, I mentioned this briefly in last week's video. This is called the discriminant. Your book doesn't really talk about it, and I'm kind of wondering why, because it's a really important point that you will need going forward in your math. The discriminant part of the quadratic formula determines how many solutions your quadratic will have. Whether that's just the parabola, where does the parabola cross the x-axis, or whether it's solutions finding the points of intersection in a system. All right, so maybe you remember, I'm going to repeat myself. Remember how the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this b squared minus 4ac, it's under a square root. So if it is negative, if b squared minus 4ac is less than 0, we have no real solutions. No solutions. What happens with just one solution? Well, look at this. If this was equal to 0 and the square root of 0 is 0, then you're adding 0 and the second one is subtracting 0. Do you see how you would get the same answer, negative b over 2a? So we get one solution when the discriminant, b squared minus 4ac, is equal to 0. And then we get two solutions when b squared minus 4ac is greater than 0. So this key right here, you should have that in your notes. This one, no solutions, one solution, two solution, with the based on the value of the discriminant. That's something that you will be expected to know in the future. Okay, I thought we'd do one more problem on the top of page 623. This is the guided practice. And in your homework, if it asks you to solve a system, I would expect you just to do the substitution. And again, if you want to check it by graphing on graphing calculator, that's just for your fun. All right, so if y equals this, which is a line, and y equals this, which is the parabola, let's set those two things equal to each other. So 2x squared minus 3x minus 2 is equal to x plus 4. Let's go ahead and move everything on one side. So subtracting x and subtracting 4, subtract x, subtract 4, would give us 2x squared, negative 3 minus 1 more, minus 4x, negative 2 minus 4 more, minus 6. Do you see how everything's even? I could put these numbers into the quadratic formula, or I could divide everything by 2, because this is equivalent. These two will have equivalent solutions. Their graph is going to look the same. Interesting, huh? I don't know if the graph would look the same because anyway, their solutions are going to be the same. Now, am I going to do the quadratic formula or maybe factoring? It looks like we could factor this. X minus 3 and x plus 1, because factoring is so much faster. And then the zero product property. So we get x is equal to 3 or x is equal to negative 1. Remember, you can't stop there. You have to plug those in to find your y. Plug it into here or here. Of course, this is easier. If x is 3, y would be 7. And if x is negative 1, y would be 3. So we have our 2 points, 3, 7, and the point negative 1, 3. And again, I won't, but if you want to graph it, you should see that the line and the parabola intersect at those 2 points. All right, let me know if you have any questions.